very happy to be here. I'm Josh Goldenhar from Excelero, and we're here to tell you a little bit about NVMe and how happy we are to be a partner, one of the first partner in storage with Open19, and we'll go forward on that. So Excelero is a high-performance server SAN. We're software-defined storage. We are a software-defined product only, so we work on any hardware, but it's going to be optimized basically for Open19. Now, a little tongue-in-cheek here. This slide is actually about NVMe. I'm sure all of you are familiar with NVMe, the bandwidth, the IOPS that it can produce, and very soon by the end of the year, also the capacity. These drives are going to go from 4 terabytes to 8 terabytes to 16 terabytes, probably by the end of the year. So you've got all this capacity, all this IOPS, all this bandwidth ability, but how do you consume it all? What can you do with it if it's only inside one server? You basically have this poor little hamster here problem, is that you've got much more than you can actually consume on a server. So what's the answer? The answer is to share. The answer is to share NVMe, make that available to multiple servers in your infrastructure. And how do you share? You share over the network. And that's why we're so happy about Open19. This platform, Open19, has been designed from the get-go to have a ton of network bandwidth availability to the hosts. It's easy to plug in, and therefore it's easy to share this bandwidth over multiple hosts with a complete switching infrastructure. It's all ready to go. You slide hosts in, it's very expandable, and it has the kind of bandwidth you need to share these new flash technologies. So why would you want to do this? Very classically, NVMe deployment challenges today, you have two modalities. You can either do it in an all-flash array, and there's some people out there talking about that they're going to support NVMe. Great! How many IOPS can one NVMe drive do? Can anybody shout out, come on, participate, 1 million, 750? It's about 1 million IOPS. I think there's a Kingston drive now that's advertising and do 1 million IOPS. A typical by 4 can do easily 750,000 IOPS. How many IOPS can an entire commercial RAID array do? There's various ones out there, I won't mention them, but they basically do the equivalent of one drive. That's how many IOPS they can provide. So you can do centralized classic storage, but how many of you are going to deploy, if you have a hyperscale infrastructure, a classic array inside your racks? I'm betting the answer is very close to 0. The other choice you have is to go ahead and deploy NVMe inside your servers, and then we have the problem I described a little bit earlier. If you deploy lots of NVMe inside of each server, you can't use it all within that server. You get the latency that you really enjoy, but you have islands of storage. You have no way to do redundancy. You can't really utilize all that NVMe. So what does Excelero do with NVMesh? We bridge that gap. We give you the power of the performance, the bandwidth and IOPS of native NVMe inside the server, but we're a software-defined solution, 100% software that lets you utilize those drives as a pooled resource over the network with complete logical volumes, optional redundancy. It lets you form your own scale-out server SAN. And if you put it on an optimized platform like Open19, what you get is the ability for an entire rack or even a row or a data center to share NVMe, pool this, make it optionally redundant, but we preserve the performance of the drives. And lastly, we fully support converged architectures. That is, lots of people say this. I don't just mean we can run our software on the converged architecture. I mean that you can run our software on a host, and you can serve up NVMe from that host without a noisy neighbor problem. That is, we don't use any CPU on the target. 0, zip, zilch, nada. No CPU. You can literally serve millions of random read or write IOPS from a host and not use any CPU on that target, which means you have all the CPU that you have paid for your applications, for your infrastructure. If someone else is using your drives, it doesn't use your CPU. This means you get better quality of service, SLAs for your customers. It actually makes a converged infrastructure that you can truly deploy and you can truly support. We're basically 3 components. Love to give you more details about this at another time, but coming at the bottom, it's a hardware abstraction layer, software only, that abstracts out the NVMe drives and makes them available over the fabric. Storage services, we do all of our services, that is logical volumes, redundancy, RAID striping, failover, all in the client. We have an intelligent client. This also makes this the world's truly only 100% scalable solution. As you add clients, you actually go ahead and you scale the capabilities of the clients. As you add targets on the back end, you scale that. You can scale these things independently, truly at near 100% efficiency. And lastly, we have the management piece, a complete RESTful interface. There is a GUI, but you don't ever have to use it if you want, with row, rack, and failure domain awareness. So we're set up for the modern hyperscale data center. You can deploy this in either modality, that is either a disaggregated, centralized solution, or you can do hyperconverged, as I discussed earlier. They both have their advantages. They both have their detractors. We're not saying how you have to do it. We're giving you the flexibility to deploy what makes the most sense to you. If operationally you want to deploy top of rack, you can go ahead and do that. If you want to do truly converged, you can do that as well. All the NVMe drives, one pool, redundancy, same performance as if they are local drives.